Okay, you're welcome to this session. Here is a question on the board, and this is on linked acceleration. So the question says two masses of 6 kg and 4 kg are connected by a light inextensible string over a smooth pulley. Find the acceleration of the system, and you are given g to be 10 meters per second squared. So these are the options. So we're going to solve this problem and find the correct option among these ones that are given. Now, when you are given this type of problem, this is actually a special type of linked acceleration called the Atwood device or the Atwood machine. If you are given this type of question, if you are still new to this type of questions, you need to draw the diagram. So let's quickly put up the diagram. Okay, so from this diagram, you can see that this is a pulley and these are the two masses hanging on either side of the pulley. In most cases, you are given the direction of acceleration of the system, but in some cases, you are required to find the direction by yourself. So in this case, this is what we'll do. This is a 6 kg mass, this is a 4 kg mass. So most likely, this system should accelerate in this manner. So we simply put our acceleration A here. This is the direction of acceleration. You can now see the various forces acting on this object. Here is the weight, which will always act downwards. So this is W1 and it is equal to M1G. This is W2 and it is equal to M2G. Don't forget there is also a tension here. We could call this one T1. And there's another tension here. We could call this T2. So for us to solve this problem, we will need to consider the equations of motion for each of these masses. So let's quickly do that. So, because there is a tension here acting upwards and there's a weight acting downwards, there are two forces acting on this same object, but the object is still moving. So there is an unbalanced force, which we call the net force. Don't forget, the net force is always the unbalanced force that results from the effect of two or more forces acting on an object. So we are going to write an equation to show that net force, and that will be Fm, which is net force, equal to Ma. Now, since we are considering, okay, let's start with M1. Since we are considering M1, we call it M1A. This will be equal to, since the motion is in the clockwise direction, it will favor the tension T1. So we have T1 as positive, and M1G is going to be negative because it is not favored by the motion. So if we substitute into this, we are going to have M1 is 1 into this equation, we have 4A equal to T1 minus 40. Again, if we do the same thing for T2, we will have net force is equal to M2A, which is equal to, since it moves in this direction, the motion is favored by W2, which is weight of mass 2. So we will have M2G minus T2. If we substitute here, we get 6A is equal to 60 minus T2. So we call this our equation 2. And then the string is an inextensible string. And when a string is inextensible, it means that the length of the string does not change. That means the tension T1 and T2 will be equal. So we can write that T1 is equal to T2 equals T. So these our equations become something like this. 4A is equal to T minus 40, and then 6A is equal to 60 minus T. I would like to solve this using substitution method. That is what I would prefer. So you can use any other method to solve these two equations simultaneously. So from 1, T is equal to 4A plus 40. Then when we substitute into equation 2, we will have that 6A is equal to 60 minus T here gives us 4A plus 40. So we open up this bracket, we have 6A is equal to 60 minus 4A minus 40. We can have 10A is equal to 20. And A has to be equal to 20 all over 10, which is equal to 2 meters per second squared. If you are required to find the tension as well, you simply pick this value for A and substitute into any of these equations to solve for the tension. So that is how you go about this type of question. Very easy and simple. So follow and subscribe for more of such videos. Thank you.